Welcome, everybody. Today's webinar is how to calculate earthwork volumes inside Civil 3D. My name is Kyle Groves. I am an EIT and a senior technical specialist here with ATG. You can see my email down here at the bottom. I'll also put that up at the end of the webinar, kgroves@atgusa.com. Definitely want to hear from you about everything that you're all up to with this. So with that, just a little bit more about myself. So again, I'm out of the St. Paul, Minnesota office for ATG, senior technical specialist. I am a Civil 3D certified professional. I'm an Autodesk certified instructor. I also have my EIT certification. So definitely been doing this for a while now, been in the workforce for about 6 or 7 years in Civil 3D that whole time. As a result of that, in my time here at ATG, I'm pretty knowledgeable in all things AutoCAD, Civil 3D, do a lot of work with storm and sanitary analysis, as well as our good old pal software, InfraWorks. With that, putting all of my expertise in that software together, working for ATG, we are here to help you out with all of your Autodesk and other needs. We can help you out with Civil 3D training. We can help you out with implementation, project development. We do production services as well. So ATG is very excited to help you out and get in with that. Now on to today's presentation. So today, what we are going to be talking about are Civil 3D surfaces. So that is going to be the bulk of our presentation. We're going to be doing most of our presentation on universal out-of-the-box workflows. We're going to calculate a simple volume surface, understand how we can work with those. We're going to build a subgrade surface that represents a known depth beneath our finish grade. This is stuff that we can use to do volume calculations. These are things that can give us a datum surface that we can then transmit to other members of the design team or a contractor. Then we're going to learn how we can automate that process using the add-on tool Earthwork Processor from CTC's Sim project suite, of which ATG is the official United States reseller for that product. But don't worry if you're not interested in that. We're still going to teach you everything you need to know to work with these tools out of the box as installed. So let's get in. Let's work over our Civil 3D surfaces. With this, the primary type of surface that we're going to be using is called a tin surface. And what that tin stands for is a triangulated, irregular network. Now, this is going to have a couple of different implications as opposed to like a perfect grid type surface. Mostly the fact that we get to have points that are not on that perfect grid, and they're going to be connected by these lines. Between any 2 points connected by a tin line, the elevation between them is simply going to be a straight slope, linear interpolation between all of those points. And because we have this big irregular network that we're using all of this triangulation on, that's how we're going to get our elevations. So we can just slap down any spot elevation label anywhere on our surface, and it's going to give us that accurate representation. Now, when we have multiple tin surfaces, and those are just planes, they might be bendy, but they are still two-dimensional. Take a piece of paper, crumple it up, flatten it back out. It's bendy, it's got fluff, but it is still one planar object. When we have those, we can then compare them against each other, and we're going to be doing that using a volume surface inside elevation. So with these volume surfaces, it's going to be looking at a single X and a Y coordinate, and then it's going to compare the elevation between what we're calling a base surface and a comparison surface. So again, because we're just doing addition and subtraction, we're not changing our units, we're still in a linear unit of just feet, not area, not volume. Civil 3D then does the math on top of that to then turn it into, okay, well, over here, I'm a little bit above my reference surface. Over here, I'm a little bit below. Multiply that by our area. That's how we get our volume calculation. But the surface itself, the thing we are working with inside Civil 3D, is just one more planar object. So what we're going to be doing today is we're going to be working with a lot of surfaces, a big old pile of them. I know it's springtime, but I've been spending a lot of time out in my yard these last couple of weeks, still cleaning up all the rest of that fall stuff. And if you just jump into this and you're getting a little bit confused, we don't want to be like this young kid over here. We want to be taking advantage of this leaf file. We want to build it up, we want to jump in it, we want to play in it. And that's what we're going to be able to do at the end of this webinar. Once we get through, we learn a couple of these core concepts, and then we get into using some of those CTC tools to help us automate all of these different processes. So with that, let's talk about our first workflow of the day, which is just creating a simple volume surface inside Civil 3D. So in order to create a volume surface, you do need at least 2 tin surfaces inside of your Civil 3D model. So in this case, we're going to have our peer EG, our existing conditions, and our finished grade conditions. We're going to create a volume surface between them, and we'll explore a couple of things like cut and fill factors. We'll set up our base surface according to the help documentation in Civil 3D. This is supposed to be the lower of our 2 surfaces, whereas our comparison is supposed to be the higher of our surfaces. Though I'll just show you a couple different ways that we can always go through and check that, because sometimes we'll think it'll be the other way around, and you always just want to check object viewer is your friend in this one. We're going to cover a couple of different places inside the software where we can create these volume surfaces. We've got our ribbon and our prospector as usual. And then there's a nice little volumes dashboard that we can find under the Analyze ribbon. We'll look at viewing and interpreting these volume surfaces, and just be aware that if you create a volume surface between 2 surfaces that are kind of close together, like our EG and our FG here, those contours are going to look very strange. So we're going to have a couple of different ways that we can look at this other than our contours. First of which is going to be a surface analysis. That's going to help us put some pretty colors and help us understand a little bit more visually where our cut is, where our fill is, how deep, how shallow, so on and so forth. I'm also going to show you how to use spot elevation labels. Civil 3D has a nice convenient feature for us to put those down on a grid. So it's another really great way to create an exhibit, or just mark that information out for your and your project team's digestion. Lastly, we'll look at the volume surface report that comes out of Civil 3D. And with that, let's hop inside the software and get to our first demonstration. So I am using Civil 3D 2021 today, and really looking forward to 22 coming out here in the next couple of weeks. But all the stuff we're talking about today is generally available in whatever version of Civil 3D that you have going back to. Most of my firms, I think the oldest is working with 2018, but this should all be in 2017 and back that far. So here we are at my site. I have a nice big existing surface I've already gone through. I have designed my finished grade surface. I have my parking lot area. I have a detention basin. And I've got a couple of alignments that are running east and west through my site. I will be using these a little bit later to kind of help demonstrate some of the practical implications of what we're working on. But for now, for this very simple volume surface, we don't need to worry about that. Another thing that I do want to point out, though, let's head over to our tool space and our prospector. One thing that I learned a little while ago when I was helping develop this workflow is you can actually create these folders inside your prospector for certain pieces of data, so you can help keep things more organized. So in this case, I have my EG and my FG surface. However, I mentioned earlier, we're going to be creating a lot of different intermediary surfaces. So you don't just have to dump these into a giant single list. You can start to organize them a little bit, and we'll have that opportunity later. But one of my biggest things I always want to remind people when we're using Civil 3D, you got to be thorough with the way that you name your objects. You have to be consistent with the way that you're organizing things. I'm less focused on what your convention is than having defined a convention, sticking with that convention, communicating that convention. Only when these expectations are properly set up and properly communicated can we really take advantage of work sharing and working as a team. So in here, let's go ahead and let's create this first volume surface. Now, I could do this by simply right-clicking on my surfaces collection, say create surface, and then go find myself a tin volume surface. Not going to do that yet. In our home tab, we can again come up to our surfaces, create, and go back and find that tin volume. But I want to get started with this volumes dashboard tool. We're going to find this one in our Analyze tab of our ribbon. And this is going to pop up using our panorama palette. Go ahead and unhide that. And when we pull up our panorama for the volumes dashboard right away, we're going to see Not a lot, because we haven't actually created a volume surface yet. So that's our opportunity to do that with this create volume surface button. Once we have volume surfaces that exist inside of our drawing, we'll have a couple of other things that we can do in here, but can't work with what you don't have. So I'm going to run that create surface button. I'm going to choose my tin volume surface, and now I'm going to start to name this. So back to conventions, every surface that I'm going to use that's going to have a volume surface component, yeah, there's a really nice graphic that we'll see in our prospector, but I always like to include a tag at the beginning of it, like VOL volume, and then an underscore. And then you should also describe, what is this volume surface doing? Well, we're comparing our EG to our FG. I'm just going to separate those with a dash. For the style of this surface, I'm going to go ahead and set this one up to a 1 and 5 design. We'll see that's going to look a little goofy, but don't worry, we'll have some ways that we can get around that. Then for our base surface, this is saying, all right, what is our standard condition? Theoretically, the help documentation wants this to be the lower of our two surfaces. But for now, we're going to see that this is our existing surface, where our comparison surface then is going to be just the plain old finished grade across our site. Now, Civil 3D does give you lots of opportunities to modify your cut factor or your fill factor. Obviously, your geotechnical reports are going to impact how this is going to fluff up when you dig it out or when you put it back in. For simplicity purposes today, I'm leaving my cut and fill factors as 1.0, but that is there. You can adjust those later on if you need to. When I create this, as soon as I do, my volumes dashboard is now going to populate. And it's pretty cool because if I scroll over, I'll see, all right, here's my cut and fill factors. I'll have a chance to modify my Civil 3D style. And then it'll get right into telling me, all right, what is my raw cut? What is my raw fill? And then what's my net? It's even got a nice little graph over here to the side. And you can toggle that with a button. On the far left, it's the little preview panel thing, but it's just going to give you that nice big representation of overall what's your cut and your fill. And we can see right away, we are very cut heavy on this site. That's much less the point of today's exercise than how do we build these surfaces? How do we manipulate them? So I now have that surface. Let's go into the drawing and let's take a look at it from the perspective of our design. So with this, my FG and my volume surface are now sharing the same style. So first thing I'm going to do is I'm actually going to select my FG surface, and I'm going to turn this to my no display. So I don't need to see it. And my volume surface doesn't look that bad. From a contours perspective, it looks generally like my site does. But let's go ahead and pop this into Object Viewer. And again, I can see a lot of the elements for my site represented here, but that's more a function of my break lines and my feature lines rather than actually like where my cut is and where my fill is. This isn't going to give me a lot of useful information. So the first thing that we're going to do to our volume surfaces is we're going to run what's called a surface analysis on them. I've got a blog post on ATG. I will communicate to my marketing department that we should get this posted into the footer of our YouTube video. But if you just go over to ATG's website, atgusa.com, under the resources, workflows, and solution, you'll see the blog post using surface analysis in Civil 3D to better understand your design. I go over how to set these up. I go over how to execute on them. Not going in depth on that right now, but we're going to go into our surface properties in order to access that information. From here, we're going to go into the analysis tab, where we get to choose a variety of different types. The one I'm going to recommend for your volume surface workflows is the elevations analysis type. And I'm going to create 4 different bins of information. Once I choose my number of ranges, I then need to run this little down arrow button to actually populate my design or whatever those analyses are supposed to be. And when I do this, I kind of like to have 4 different categories of information. I like to have heavy and light, cut, and fill. So right now I'm seeing that the lowest elevation of my volume surface is minus 16 feet. That's great. I'm going to leave that alone. From here, I basically call heavy cut or heavy fill anything outside of 2 feet. So my fill there is going to be minus 2, And this is going to be from -2 to 0. From now I'm transitioning into a fill situation. So now I'm going from 0 to +2, and I'm not going to have anything above that. So I'll go from 2, sorry, my maximum, we'll just call that like 100 feet. And then our minimum for that range will be 2. The other thing that I need to do is I need to assign these colors. So cut is generally red. I'll use red for the heavy stuff. I'll use an orange value for my lighter, shallower areas. Green for fill, we'll use that for our big area. And then I'm going to use cyan for kind of our shallower fill situation. So I've got myself a nice little pretty rainbow. That's going to work great. Now I can say apply, but I'm not actually going to see this show up inside my Civil 3D model. And that is because my surface style is not a style that's going to show those elements. So with this, I'm going to now change my surface style to the elevation banding style that's set up within my template. And if we go and we look at the modification or the actual setup of that style, what we're going to see is that the only element that is turned on in my display tab is this elevations light bulb. So pretty much everything under minor contour, the rest of these light bulbs all represent those different analysis types. So you can run an analysis, you don't have to view it all the time, but whenever you do want to look at it, you need to have a surface style with one of these corresponding light bulbs turned on for the display. So I've set my elevation surface style, I hit OK, and now as soon as I close out of that dialog, I've got these nice pretty colors telling me, oh, the fill is in kind of the west half of my site, particularly in my green space. However, noticeably, where I have my detention basin, some of these other low spots in my site, I'm in really cut heavy conditions. And because I set up my gradients the way that I did, I know that orange is a little bit of fill or a little bit of cut, and then the red is the really deep stuff that I've got to deal with later on. So that's my color coding. And I've got decent information with that. But another way that we can get more specific information about our site is to put down our spot elevation labels and to do that on a grid. So next up, I'm going to come to my annotate ribbon, and I'm going to do the add labels. Whenever I add labels inside Civil 3D, I like to be deliberate, I like to be thorough, I like to be specific about what styles are going to go down. And the easiest way for me to do that is to access my annotation through the annotate ribbon. And then whatever element type I'm choosing, I'm going to choose this top type, add whatever object labels. When I do it this way, now I have a dialog that pops up that actually gives me an opportunity to choose what type of label I'm going to create and why I like this so much, what style you're going to use. If you go in and you use any of these other options, your template has a setting, use this style by default. Now, it's great if you want to have your template set up, if you like those styles. I'm just usually in a situation where I want that flexibility. I want to know that I can put down exactly what I'm looking for. And that's why I really like to make sure that this dialog is up before I go through and add those to my drawing. So spot elevations on grid, I'm going to be using the special volume cut fill label style. I've also got another Tech Talk. This is ATG's short form informational series on how to create these labels inside your template. Short answer is we're using an expression to modify the text height of those labels. So I'm going to start adding those labels. It's going to ask me to choose one. I'll press enter because I want to be super thorough about this. I'm going to choose my volume surface, press OK. And then the grid base point, you're always going to want that to be in the bottom left of wherever it is that you're choosing. So I'm going to go a little bit outside of my site. I'm going to choose a 0-degree rotation. And then it's asking me for my spacing. Now clicking will choose something in my drawing that's a little extreme. I'm just going to type in, I want a 25-foot X and Y. You can have those be different too. You don't have to use the same square grid spacing. Press enter to accept that. Now it's asking for my upper right corner. To do that, just like I started a little bit outside my site, I'm going to finish a little bit high and a little bit east on that grid. It's going to give you a preview. The big outer grid is your whole grid for that. And then there's even a little rectangle in the inside corner showing you what your spacing is going to be for that grid interval. It's going to ask me to confirm, do I want to change anything? That answer is no. So I'll press enter. And now I've got all of these labels that just showed up inside my drawing. To make this a little easier to see, I'm just going to leave it because they've got background masks on them. So with this, every 25 feet in my drawing, I now have a Civil 3D surface elevation label. If anything about the surface it's informing changes, it's going to update automatically because this is just Civil 3D annotation at its finest. So even if I were to go through and physically move this label, we can see those values updating in real time based on where it is in that surface. So these are the two methods I'm going to recommend that you use for preparing your exhibits, for passing this off to the rest of your design team. Just anytime you want to visualize this information, consider running an elevations analysis on your whole surface. It's going to give you your pretty colors, and then create this volume label style for your cuts and your fills. I also set mine up so that it's green in a cut condition and red in a fill condition. Sorry, flip those, green fill, red cut. Context is key, context is everything. So that's it. That's how we're going to go through, and that's how you can create a simple volume surface inside your drawing. Except it's not really how our design is going to work, right? Like, yeah, I have my raw FG, I have my raw EG, but what happens when I need to strip information or strip my site because I've got bad cover situations? What happens when I have different amounts of engineered material going through my site? Turn on a few more layers here to see, okay, well, in this site, I've got open green space where I'm going to have 6-inch topsoil respread. I've got my standard passenger vehicle parking lot area where I don't need super heavy duty pavement or a really thick base section. And I've got my heavy duty pavement area where my garbage trucks and my loading docks are going to be accessed. Other areas where I'm just going to have different depths in here. So I need to know what is the bottom of my engineered material section. That's really what I want to compare to my existing grade, whether it's raw or whether I've gone through and done stripping on that and removed further material. Plus, my contractor might want to know, hey, can you give me a Civil 3D surface? I don't want to read your plans. I want to plug this into my machine grading software. So let's take this one step further. Let's see how we can make our model, make our site just a little bit smarter. That's what this next workflow is going to be doing, is we're going to be creating a proposed datum surface inside of our model without using corridors. And corridors are great. I love corridors. Some of the most fun I can have inside Civil 3D using corridors, but they're really clunky for a Civil 3D site design workflow. So to get this without our corridors, first thing that we're going to be doing is we're going to be building some polylines. Theoretically, we could also use feature lines if we have variable depths. But basically, we're going to be outlining the different parts of our design that have a constant depth. This is going to help us give our area. We're going to be using this for our volume calculations. So I'm going to suggest use a closed polyline. The boundary polyline command is really great. I'll show you that one in there to go through and do that. But you'll be copying objects, you'll be trimming, you'll be putting them on different layers, so on and so forth. Biggest thing with these boundaries is you don't want them right on top of each other. Civil 3D surfaces are limited, just like a lot of other surfaces in civil engineering design software. Only one elevation can be assigned to a specific X and Y coordinate. So because these polylines are going to be at different heights, we want them to be just a little bit offset from each other so that Civil 3D isn't going to throw a warning or throw an error that we've got multiple elevations in the same area that we're trying to define. The other thing that we're going to note about these polylines or these feature lines is wherever we're defining the elevations for these, we're going to be assigning a depth or an elevation rather, and that elevation is going to be the positive value or the absolute value of how far underneath this polyline would be beneath our finished grade surface. So when I said before that I had a 6-inch topsoil respread area, I would define the elevation of that polyline at positive 0.5 feet. And it doesn't make sense now, but it will later. Once we've got those polylines set up, I mentioned we're going to just be making a whole pile of surfaces. We're going to have a lot of those to sift through. So the thing that I need you to keep in mind is that when we're doing a volume surface, we're still just doing addition and subtraction. We're not changing a linear unit into an area unit or into a volume unit. Our volume surface is just comparing two elevations, and it's giving us the result. A plus B equals C. Switch your minus sign, switch your positive sign, but this is the equation that we're working with. Also important to remember, volume surfaces are still just planes. They might be bendy, they might be small values compared to our raw existing elevations or our FG elevations, but they're still just a single plane. And we're going to need to create a couple of intermediate surfaces to get to those overall volumes. Where this is going to be helpful, we can do this in situations where we need to provide a subgrade or a datum surface to our contractor. Just note, I'm using datum and subgrade interchangeably. That is the exact same word for my purposes for this webinar. I will use different ones at different times, but I mean the same thing. It's the bottom of our engineered material for our proposed design. And then we're also going to want to use this for detailed earthwork calculations when we're trying to do our site balance and our volume calcs for our project. We don't want to implement a design that's going to be 100% cut or 100% fill unless we absolutely have to, because that's really expensive. It's one of the most expensive things we can do in civil engineering is moving dirt when we don't have to. So with that, that's what we need to know. Let's talk about the workflow and hop in and do that. So our first step is we need to create boundary polylines or boundary feature lines representing the edges of those engineered materials, and then we need to assign those depths to them. We're going to create a standard tin surface using those elements. So this surface is going to have an elevation very close to 0, probably not more than 5 feet, unless you're doing something really crazy with your site. And then what we're going to do is we're going to create a volume surface, because what we're trying to do is we're trying to get a little bit underneath our finished grade. So we want to take our finished grade, we want to subtract that material depth, and then we want to end up with our finished grade subgrade a little bit beneath that. And that's why we're defining a positive value for the material depths, because we want our overall subgrade number to be smaller than our starting finished grade number. Always, every single time you go through this workflow, take your resulting surfaces, pop them into Object Viewer, and confirm that you did your base surface comparison surface thing effectively. I've taught this workflow for a while now. I still mess this up from time to time. So always confirm that, use labels, throw it into Object Viewer. So this volume surface is going to give us an elevation that represents our finished grade subgrade. But that's not the end of our workflow. Not if we're trying to get to our site earthwork balance and we're trying to compare our finished grade subgrade to our existing to get that true site-wide cut and fill. However, we're going to run into a problem here, because this FG subgrade surface cannot go in to another volume surface because it's a volume surface itself. Civil 3D volume surfaces cannot be used as an input. So we need to create a copy of that surface, a clone of that surface that is actually just a standard tin surface. The way that we're going to do that is we're going to use the paste surface command from our edit list, and then we're basically just going to say, hey, FG subgrade, you are the definition of this new tin surface. And now that we have two standard tin surfaces, e.g. and our modified, now we can create that true site-wide volume cut and fill surface. So with that whole big mess, let's get it organized. Let's go hop into the software and check it out. So I've already gone through, I've created all of my boundary polyline work. Everything has that really small offset going on associated with it. Just isolate these layers real quick, kind of show that off. So really just working with 4 closed polylines. This white one is for something else in my workflow from the last time I used this data set. But I've got 2 separate 6-inch subgrades. I've got an 18-inch subgrade, and I've got a 12-inch subgrade. And the elevations on these are all positive. So for my 12-inch subgrade, I'm at a positive 1 foot elevation. positive 1.5 foot elevation for that 18 subgrade. Because algebra. If I unisolate, show you real quick how to use that boundary polyline command. If you're trying to come up with those, that it can be a little time consuming. It's just standard drafting work. Create some random shape here. Let's go with a star. And now if I wanted to grab an isolation of any of these, I might need to copy objects, I might need to trim or extend or do some of that stuff. Nope. Coming into our good old fashioned home tab, in the draw panel, we've got our hatch command, but in that flyout, there's the boundary command. So this is going to say, all right, what are you doing here? Well, we're going to do some island detection. Basically, just say OK, and then click inside that object that you're looking for to get that closed area. And you can kind of see it highlight there for me, but I'll press OK. And then I'm going to select my star. I'll erase the star. And what I'm left with is this closed polyline. So that's going to give you, as long as you can get the outside couple of elements isolated, it's going to save you a little bit of time in doing that workflow. So now what I need to do is I need to take these polylines and I need to add them to a surface so I can start doing that addition and subtraction using my volume surfaces. So I am going to come over to my prospector. I'm going to make sure that I have a folder for all of this. So all of these subgrade surfaces that are not my volume surface for my final stuff, they're going in this folder. So I'm going to first create a surface. All right, so this is my subgrade. Couple of different ways that we can keep this data organized. Number one, number your things or give them some sort of an order. So the first surface that I'm going to use, I know I'm not really going to be interested in that for final calcs. Also, I'm just going to put in the name right here. Hey, our elevations are going to be near 0. Just one more logic check for me to be able to find that. For my style on this one, I guess I can go with my triangles design in tin just to make sure that it got created. I'll say OK. And then for my definition, I'm going to grab these polylines. Don't want the white one. And contours, add subgrade depth. Supplementing factors, I'll go ahead and I'll add those. 25, I do have some curves. Let's use 0.5 on that. I don't want to play with my flat edges. I really just want, I do want things to be flat and I don't want those corrections because this is where we're going to be for all of that. Clear those events. And now I've got a surface. If I look at this and I compare it to my FG, I should notice sorry, got to turn the FG on. So this is part of where this workflow can feel a little clunky. Managing your styles, what can you see, what can you not see. But I've got my FG and that near 0 surface, and we can see that they are very far apart. So that's good, that's what we want. Next up, we need to create the volume surface so that we can subtract our proper FG number, and we can reduce it by a little bit, somewhere between 0.5 foot and 1.5 feet, and that'll give us our datum. To do that, we're going to be using a volume surface. So I'll come back to my Analyze tab, go to my Volumes dashboard, and I am going to create a new volume surface. For this tin volume surface, I'm going to be calling this vol. I call this true subgrade. Now, for my base surface, this one is going to be my FG, I believe. And my comparison surface is going to be my subgrade near 0 surface. And we're going to check this. And the style for this one, I'm going to assign this as my, I just need it to look different so that I can compare them in Object Viewer. I'll give this a background style. So FG, subgrade near 0, we'll say OK. This is my subgrade surface. I'll grab my FG surface, and then I'll grab those tin lines. I've got all 3 of them. Now we can pop them into Object Viewer, and we'll see if we got that correct. Not quite. So what we were looking for was for these two surfaces, my FG and my subgrade, to be really close to each other. So I didn't get that right. No worries. We can delete and try that again. So go back to create surface, create volume surface. Subgrade, base of the near zero, compare with FG. Background. Pop those back into Object Viewer. That's better. So things don't look too different. I've got my FG up top. I've got something hanging out down on the bottom near zero. If I zoom in though, and I get really close and I take a nice ISO view of that FG surface though, I can see that right underneath it, I've got that gray color. That's representing the existing style that I had assigned. If I come over and look at that cutout where my building is, again, I can see that I'm a little bit offset there. So this is exactly what we're looking for. Second thing that we can do is we can come in and we can put down a couple of spot elevations and make sure that we are near where we're supposed to be. So I'll grab a spot elevation label. For you, you're at 834 on my subgrade surface. And that means that this should be like 835 or so on my FG. If you have my FG selected, I'll grab a surface label and I will hit that same spot. Oh, that's perfect. So my FG label is at 834.5. My volume surface label is at 834. And I know that I'm supposed to be 6 inches underneath. Sorry, I tried to grab that polyline. I'm supposed to be 0.5 feet underneath, and I've got that positive elevation assigned. So this is working correctly, and this is why we check. But that's how it's supposed to go. And that's why we also have the positive elevations assigned with all of these boundaries in our geometry. So that's cool. And this volume surface, this works. I can give this to my contractor. They can use this as a datum-wide surface for the site, throw it into their AMG, do whatever they need to with it. But this isn't going to get me as far as I need to go for my overall earthwork balance on my site. I still need to compare this to my existing to get that volume. But I can't use this surface as an input for that process. I need to use it, or I need to convert it first. Real quick, do some organization. I'm going to start dragging surfaces into my subgrade folder. It's just that easy. Select a surface, drag it into its folder. I'll also rename this volume surface to O2. Keep that serial pattern going, be consistent, be thorough. Next up, I need to create my translation surface. So this is going to be just a standard tin surface. Call it O3, subgrade convert. And for this, I'm just going to give it a no display style because we don't need to look at it. And I'm already getting my screen moderately cluttered up. Let's see what else can go away. We can turn off our near zero. We're done with that. And then the true subgrade, we can leave that on, but I don't want you with a background. I'm going to change you to design with tip. So now with our subgrade conversion surface, let me drag that up into our subgrade collection for that folder. This one is going to be really simple. We're just going to come into our prospector. We're going to expand its definition. We're going to right click on edits and we're going to say paste surface. And the surface that we're going to paste is that volume subgrade surface. And now we've effectively created a copy for it. With this copy, we can go into our volumes dashboard. We can create a tin volume surface. And this is our volume EG FG datum. Go ahead and I will give this one my fancy colors with that elevation banding. And our base surface, this one should be the EG. And our comparison, this would be the subgrade convert. Notice when we're trying to choose these, we don't see any of those volume surface icons. So one more confirmation that we did have to do that conversion step. And now I will say okay. And whenever you create a new surface, you do still have to run your analysis in order for those colors to be defined to take effect. So I'm going to find my volume between my existing and my datum. I'm going to go into my surface properties, and we're going to redefine that analysis. Elevations 4, -2, -2, 0, +2, 0, +2, arbitrarily large value, +2. Not quite right on the colors. This is orange. Cyan's good. Flop the purple to a green. And that's better. Okay, so looks like even after we drop our FG a little bit to get to that true datum, we're still extremely cut heavy on this site. To confirm that, let's take a look now at our alignments and our profiles to see how this is really happening. So I'm going to choose my parent site cross-section alignment. I'm going to come up to my surface profiles, and I'm going to pull out my EG and my FG. Definitely want those two. I want my subgrade, and that should be what I'm looking for. So my existing, I'll leave that as existing. My FG, I can change that to my design profile, and my subgrade, I can convert to a design subgrade style. I've already got the profile view, so I don't need to draw them. So I can come over here and I can look at this in my site section and in my profile. Also going to just quick chop up my viewports from the view tab, viewport configuration, and kind of take a deeper look at this. Declutter with some of my visual characteristics. So as I'm going across my site, what am I seeing in my cross section in this profile view? Well, I'm starting out in my 6-inch cut, or my 6-inch topsoil respread datum area. So I can see a little barrier over there. Then I'm going to go and I'm going to travel through most of my site with that 1 foot wide depth, or that 1 foot deep. And then as soon as I cross my like station 250 to 275, I'm crossing that heavy duty pavement area, and I can see that little drop in there. So this is telling me that I have correctly identified and correctly modeled those various subgrades. So that's good. And then I'm going back into my 6-inch because it's standard topsoil in my detention basin area. But this profile view is telling me very clearly, like, hey, I am extremely cut heavy. I will want to do a lot to try and bring this site up. Otherwise, we're going to be just dumping we're going to be getting a bunch of soil out of here. But overall, that's our process. That's how we can go through. At this point, let's get a volume report out of Civil 3D. So we've talked about the banding and the analysis. We've talked about the spot labels. Let's make sure. One thing when you're working with the volumes dashboard is if you ever create a volume surface outside of the dashboard, you're not going to see it in here. So this very first button on the left is, hey, do you have any volume surfaces that are not being accounted for by the dashboard? So if you do that, you'll say okay. The next button is to create that. But notice how I just magically transformed from way cut heavy to way fill heavy. All of these volume surfaces that have been added to the dashboard, they're going to be added up in summation. So this isn't quite what I want. What I want is I really just want my EGFG datum, and I can remove the other ones out of the dashboard. This is the one I want. And then now when I create my cut and fill report, It's just going to include that surface. This comes up as a little XML report, basically. It shows up in your Windows browsers. I've got IE, might see it in Edge too, but it's got your cut, it's got your fill. You print this out, you include it in with your plan set, and that's typically how Civil 3D wants you to export this data. So we've covered all of those major factors, but that was a lot of surfaces. I had to create 4 different surfaces just to get to my site-wide datum, and I had to create 2 surfaces that were an exact copy of each other just to represent that subgrade. What I'd like to talk about now with some of my remaining time is how we can start automating this process using the CTC Sim Project Suite. Specifically, we're going to focus on that Earthwork Processor tool. Let's pop back into PowerPoint. I can tell you a little bit about it before I show you a lot about it. So with Earthwork Processor, what we're doing, also too, if you have any questions, please feel free to type them into the Q&A window or the chat window. We'll also be sticking around for questions after the end of the presentation, but I did just want to mention that. So with Earthwork Processor, what we're going to be doing here is we're automatically creating those intermediate and those final surfaces for that material quantification. The objects that we're going to be using for that, we can include those by either direct selection, or we can create a filter that's going to go and collect different objects with particular criteria. We're going to be able to also account for stripping of our existing surface, and we can even do that by region. So if we have different geotechnical materials, some of them are lower quality or higher quality than other, we can really drill into just how much material we have to remove from our existing. With this tool, we can also create AutoCAD tables and Microsoft Excel files that we can then use to increase the quality of our deliverables or to plug into our other QTO calculations. Also, part of this is to come up with numbers that we're going to make decisions about our design, and our design process is very iterative. So when our design changes, all we have to do is rerun the Earthwork set, and it's going to automatically update that data for us. We don't have to worry about, well, do I need to build a new surface because I added a new polyline? We don't have to worry about that. The tool is going to manage that for us. So what's the workflow going to look like when we're using Earthwork Processor to manage these calcs? Well, it's going to look very similar to the one we just did. We're going to need those boundary polylines or feature lines to represent our engineered material depths. But from there, the tool is going to do all the hard work for us. So you're going to open the tool, and we're going to create what's called an Earthwork set. This Earthwork set is going to allow us to define different regions, like those 2 grassy areas or the heavy duty pavement that I had, and certain parameters associated with those regions. We're going to run the Earthwork set, and then we'll have an opportunity to view the results from that. At any point, if we need to iterate, no big deal. We simply reopen Earthwork Processor, and we run it again. With this, we can have the tool also help us automate our annotation, automate the visualization, and reporting that we can all find in our options menu for the tool. I don't think I'm going to have a ton of time to go through all of those, but just want to mention that they exist. So with that, let's take a look at how this is all going to work now using Earthwork Processor. So I really just need to turn off these other surfaces. I've just got EGFG, great. All right, so when you download the CTC tools, you're going to install them. You'll now have a new ribbon inside Civil 3D. And in the Sim Project Suite, I'm looking for my grading panel where we'll be checking out Earthwork Processor. I don't need that set. And this is what you're going to see when you get here. Big empty open dialog with a couple of buttons on the right. So with this, we need to have an Earthwork set before we can manipulate it. But we can do things like save these parameters out so that we can reuse them in other parts of our drawing. We can create AutoCAD tables. We can create Excel files. So I'm going to create my new Earthwork set. I'm going to name it Earthwork set. And I'm also going to expand it. We'll see I don't have anything defined in here yet. So first thing, if we're doing volume surfaces, we need to come up with a proposed, which in this case will be my FG surface, and an existing, which is my EG. As far as my subgrade regions are concerned, I could come through here and start, like I did before, manually pick that polyline and go through and do that. We'll see them show up here in our set. That's really tedious, and it's not very encouraging to our users to get them to follow our standards. So what I'm going to show off is the filter capability, where as soon as I then press that ellipse, it's going to say, all right, what do you need? Do you want to include things on the basis of layer, style, or site? Do you want to exclude certain styles or sites or other information? I'm just going to keep things simple and include. I don't even need to know the name of my layer. I can simply run the green pick cube to go through and identify that info right away inside my drawing. So I can grab the purple line and I can grab the yellow line. And then if I want to check what I've got selected, I can run the ellipse button. So this is telling me I have my 6-inch, 12-inch, and 18-inch subgrade surfaces. Now when I press OK, it's automatically going to find both of my 6-inch subgrade polylines, and life is going to be good. Because I had already assigned my elevations to those polylines, they're showing up in here with that subgrade depth already filled out. However, if I want to change that information, I can simply check the box and say, this is actually going to be 0.67. I want 8 inches of topsoil rather than 6 inches, so 0.67. And note that it's got all this information set up as out of date. I haven't built my actual surface yet, or my network of surfaces yet, so that's makes sense. Stripping depth, I'll go with a 1/2 inch. Basically, we're just trying to save all that organic material. We've got decent soils here on this site. I'm going to leave the labeling. I'm going to leave the shading alone for that for now. Simply going to run my earthwork set. And then we'll see, the tool is also going to automate the creation of one of these folder groups for me right inside my drawing. So if I go to, move my 04 into the subgrades. So if I go over and now I see that earthwork set, that was the name that I had inside Earthwork Processor. So I've got a bunch of different surfaces in here. So first up, we have our stripping surface. So this is going to be a certain distance beneath our FG. If I go check my my definition tab, it took those different regions and it dropped them by the volumes or by the depths that I had specified. So then it goes through and creates a volume surface comparing that drop down to my existing. I've got a subgrade surface. So this is what we did in that middle workflow, is it subtracted somewhere between 8 inches and 18 inches, and it created that subgrade surface. Then it created a volume specifically comparing my subgrade. Go check my volume surface stats tab. Now it's comparing my finish grade surface to that depth underneath my subgrade. So it's going to tell me not only where that bottom is, but also how much of all that engineered material that I need to bring in. It's another very useful quantity that we'll have to take out. And then we've got our actual earthwork volume surface. This is the surface that's going to be comparing my stripping, because I had that in here, to my actual subgrade. So whatever combination of surfaces that you need to have, Earthwork Processor is going to make almost all of them for you. It is a strict workflow for that, but we can see that that's how that's going to go. And the volume surface that I had created for me and set to that banding was my actual earthwork volume surface. And if I run my, actually no, I don't need to manually run that analysis, because Earthwork Processor can do that for me. Hop back into Earthwork Processor. I'm going to go check out my options. In my options, I can do things. So these earthwork sets, these can be saved and loaded. I've got a location that I can put out for that. For my surface creation, this is going to tell me, this is pre-populating which one of these are going to show up. That's why my earthwork was the only one that did show up. And I've got that same 2 foot, 0 to 2 foot, 2 foot to extreme. And now I'm just going to press the shading checkbox to have that go in. The other thing I'm going to do is I will create some labels that go along with this. We've got a lot of different options for them. Basically, I'm just going to keep the highlights, name, cut, fill, net, and then any stripping that I have associated with that too. A lot of different ways that we can play around with that. CTC has some great webinars digging more into how to set the tool up, and ATG is going to have a couple more webinars on this tool set in a little bit. But I'm going to just label individually my 6-inch and my 18-inch subgrade sections. So we'll let that all kind of run. Close. And just like I was before, I'm still in a very cut heavy situation. So what I'm going to do is I'm just going to pick my site up. I'm just going to pick it up. I'll go into my prospector. I'll go find my sites. All the feature lines that are in my main site, those are the ones that are defining my actual FG surface. So because I've organized my drawing very well, I can simply go to my site, select all of my feature lines through right-click selection, and I can raise and lower, and let's pick them up at 1.5 feet. Now my volume surface did kind of automatically rebuild a little bit, but let's go back into Earthwork Processor and get everything else to update. Just need to run my Earthwork set. Now all of these numbers are going to flip from out of date to of an actual volume. I did not have my net written down before, but it looks like we're at about 4,000 cubic yards of cut. So I can keep going up. Let's just run that one more time. Raise by another, let's do 1 foot this time. Earthwork Processor. Run. We had like 4,000 cut before. Ooh, we're less than 1,000. I'll call that good. So I can see that where I'm having the cut and fill borrowing in my screen. I can add annotations. I said Earthwork Processor was going to throw down some labels for us. Let me turn off that volume surface, and we could see here are those pieces of MText. Now they're going in at the centroid, and they weren't set up as annotative. Those were options that I could have chosen, but it's got in here in my heavy duty pavement. It's telling me what my depth is. It's telling me what my cut, my fill are, all my stripping volume. It's going to automate that. It's going to update that every time we add that data or rerun that data inside of our drawing. We can create an AutoCAD table. We can create an Excel table. Earthwork Processor is really just going to bring the automation back to this process, where before we were working in a very manual, very slow, very tedious process. However, it's still something that we can do using out-of-the-box tools if you're not quite ready to pull the trigger on the Sim Project Suite from CTC, which has lots and lots of other super great tools in it too. So with that, I did say I want to leave some time for questions. And so to conclude for today, we learned that volume surfaces allow us to easily and quickly compare elevations between different tin surfaces. We learned that our site datum or our site subgrade surface regions should be represented by either polylines or feature lines, and those elements need to have their elevations reflect their depth underneath the FG surface, and we're going to do that with a positive elevation. By thoroughly understanding our volume surfaces, we're allowed to manipulate them, and this is going to help us better understand and better represent our designs. With that, we can then use CTC's Earthwork Processor tool to bring powerful automation to our creation, organization, visualization, and our annotation for all of these different surfaces that we need in our site balance workflows. Thank you so much for your time, everybody. And do please check out ATG's social media on LinkedIn. Check out our YouTube page where this video and many others like it are up for 24/7 access to that content. This time, I'll open up to some questions. James, I'll hit you first. Can we get a download of this video? Download, not unless you have YouTube Premium. However, this will be up on ATG's YouTube page within the week. Usually it's like a day, maybe 2. But yeah, come back, check out the ATG YouTube page, look for this video, send that link, tell people about it. Would love for that to happen. Anonymous, the subgrade near zero surface. Can we go over that again? Yeah, for sure. So I'm going to hop back here into Civil 3D. And what we're doing with this is we're just doing algebra, and we're tricking the software into giving us the information that we're looking for. So I have a finished grade surface. That finished grade at this point in time is at, oh, hold on, let me drop my feature lines back. See, I went up 2.5. Yeah. So I have a finished grade surface. Wherever I'm at for that finished grade surface, I am at a particular elevation, and I want to go beneath it. So what I'm going to do is I'm going to take 834.5, and I'm going to subtract 1/2 of 1 foot to get me down to 834 feet. So what I need to do is I need to take 834.5, that's my arbitrary elevation anywhere on my surface, and I want to subtract a positive number, which will give me something lower than my initial value. So 834.5 subtracted by positive 0.5, or actually Earthwork Processor updated that for me. So subtracting positive 1/2 from 834.5 is going to give us our 834. So these polylines, they can be feature lines if they need to vary in their height over the space. This surface is going to be very close to 0 so that, rebuild, automatically rebuild. So that true subgrade surface is a volume, because what we're doing is we're taking that's very small but positive number, and we're subtracting it from another positive number, hopefully. And that's what's going to give us our slightly lower value. Let me pop those all back into Object Viewer again so that we can see those appropriately. Subgrade near 0, design with 10, true subgrade. Bam. So I'll grab subgrade near, grab true, I'll grab my FG, put all 3 of those into Object Viewer. So this is my near 0 surface down at the bottom. My FG is clearly visible, but then right underneath that, value minus 1/2 equals this little cyan surface hanging out just underneath my FG. That's how we're getting to our site-wide datum. Whatever those values are, it's going to bend, it's going to get there, and that's how we're going to get to that result. So I know it sounds goofy, it sounds backwards, because it does, but ultimately that's going to get us where we're trying to go. So with that, again, still have some more time to hang out for questions if you folks have them to be asked. Thank you again for all of your time and your attention today. I do sincerely appreciate it. While we're kind of waiting for some more of those to pull in, I will plug those other 2 cross-references that I had mentioned during the webinar. So if you want to create those cut and fill volume labels, I've got a tech talk on that. It's called Creating Cut and Fill Labels for Volume Surfaces in Civil 3D. And then on our ATG USA page is where we keep our blogs. You're going to find those under the resources page, and this is workflows and solutions. I think right now this one's buried on like the 3rd page back. Marketing is working on getting these updated, but I will direct them to include the actual links to the actual posts in the description of the video for this recording. And if you're looking to get your hands on the Sim Project Suite from CTC, definitely go ahead and check out ctcsoftware.com, where you can go then and find their products page for the Sim Project Suite. And in here, you'll find all the different tools, but we've got, you can download the suite itself. It is a full download, 100% functionality for 2 weeks. You can download the sample files that we use to demo those off. If you do decide to try this and you're not quite ready to buy it, don't worry, we're not going to lock you out of any of your files. CTC tools do not hold any data for ransom. We don't think that that's a very ethical way to do business, and so we choose not to. Brian was asking, what was the YouTube video we showed? So I had demonstrated Brian a little trick for some volume labels, spot network labels specifically. What these do, the way that I built them, is they are, it's one label, and it's going to be in a cut condition, it's going to show up as red, and in a fill condition, it's going to show up as green. And what we're doing is we're just taking advantage of a couple different pieces so that it's really bright and obvious when you put that down on your screen where that's going to be. So if I add that to my subgrade, subgrade surface, not my subgrade surface. Earthwork. Somewhere down here, no rotation, 25-foot grid, up over this way. Do not change. So with these, wherever we're in a cut condition, it's going to be red. Wherever we're in a fill condition, it's going to be green, but it's all just one label object. And if I turn off those fancy colors and zoom way, way in, I'd actually see that there is another label component down here that is the very, very small version of the fill label, which would be positive in green. We don't want to read that. So that YouTube video is called Creating Cut and Fill Labels for a Volume Surface in Civil 3D from the ATG YouTube page. You'd find that one under playlists, and that is in the ATG Tech Talks playlist. And again, for any of the folks that are wondering about downloads for this video, future watching for this video, if you signed up for this webinar in advance, you will be getting a notification from our marketing team when that video goes live. That video will go live onto our YouTube page somewhere. I'm not sure exactly how our playlists are getting organized for webinars these days. But don't worry, you will get a link to this video so you can check it out for posterity. And I am also going to try and get my marketing team to directly link the YouTube video on the labels, as well as my blog on how to use a surface analysis. And you know what? I'll do folks one better. If you're in the chat window right now, I will paste those links so you can grab those. And bookmark them for your use. I'm sorry, folks, I missed some questions earlier in the chat window. I was looking only at the Q&A. So Scott, thank you for your patience. I do apologize. So wanted to have the ability to swap base and target surface. Is that, or will that be available for at some time? Yeah, I don't know that's an Autodesk question. And if you're not seeing it in there today, then it is not in there yet. And I don't know if that's something that they're going to go through and give us the opportunity to flip. Looks like in 2021, that is not the case. So unfortunately, Scott, Autodesk is still just got a couple of those low-hanging fruit that would make the user experience way better, but they just don't. So that's unfortunate. I had another question come in here. How do we handle large surfaces or large files that become slow when we have to create all of these different surfaces for those volumes? If that data is in the drawing, it's going to cost bytes. However, my favorite way to keep drawings running clean and smooth is to take advantage of a no display style. So we'll notice actually that when Earthwork Processor runs by default, it has an opportunity to define it's in your options, it's under your surface creation. So for those by default, or you can change that for an Earthwork set, it's going to ask you what surface style do you want to use. Well, you should be using a no display style whenever you want data to go away and not be visible, because that no display style is also going to really enhance your ability to, or it's going to decrease the amount of calculations Civil 3D has to do in order to get through all of that. So if I go to my surface or styles, no display, a no display style is extremely simple. It is just your display tab for most of your objects. Alignments have some markers that you need to care about, but you go to your display tab, you go through all of your view directions, and you just turn off all of the light bulbs. With that set to no display, you're going to have your drawings running way lighter weight, and it's also a lot more convenient, in my opinion, than freezing the layer of the source object, because Civil 3D styles and AutoCAD layers have a lot of strange interactions. Strongly suggest your Civil 3D stuff, you don't want it, you turn it to a no display style. Is the easiest way to keep track of all of that data. But hey, yeah, loving the questions. Thanks for that, folks. Definitely happy to stick around for another few minutes if anybody else does have some more questions. And one more time, thank you so much for your time today. All right, folks. Well, it looks like we're a little bit after the hour, and we're starting to dwindle down to the last couple of attendees. So thank you so much for your time today. If you do have any more questions, let me know. Oh, hey, Vernon, are there more videos using the corridor tools in the Sim project suite? There sure are. So 2 places you're going to want to go, Vernon, to 3 places to learn more about the CTC tools. Number 1 is going to be the help documentation. So all of the CTC tools have a ribbon up at the top, a couple of different things. The help button will launch the PDF help doc that ships with the Sim project suite. It's very robust, very thorough document, goes through, does a lot of the more buttonology type stuff. What is this button? Where does it live? Why do we want to press it? But right now it's at about 60 pages for the current iteration of the suite. So you can definitely go check out any of that stuff. The other thing is that there's a videos button at the top of that ribbon. And when you click on that, it's going to take you to the CTC Software YouTube page. And there's actually a playlist that they have created for each individual tool. So if you had one of the corridor tools like Merger open at that time, then you click that video button, it'll take you there. Otherwise, the CTC Software page, I like to go to my Civil Express tools playlist. And then this is going to have all kinds of stuff on all those different tools. So I'd say here, the CTC page is more universal learning information. So this is how do I get started with the tools? How do I CAD manage the tools? How do I get this set up to work well with my firm's standards? Check the CTC videos on those. They're really helpful for that. ATG's videos on our page are a little bit more of the format that you saw today, Vernon. So this is, hey, we're trying to show folks how to do things in the software, and wherever we have an opportunity to say that the CTC tools can help bring automation, can help make your life simpler, faster, more efficient, then we'll incorporate them in that way. But there are a good number of videos in here that do have aspects of the CTC tools. They're just a little bit more theory-based in the universal workflows, and they're a little bit more tangential in like, we're using this tool for a specific task, if that makes sense. Does that answer your question, Vernon? Excellent, thank you. All right, folks, and with that, I got 1:15 Central. So I'm going to go ahead and call it. Thanks for your time today. Have a great rest of your week and stay safe out there.